All right, good morning, everybody, or I guess good afternoon, since that's when you'll be watching this. Today's lesson is, to be honest, the first half of it is a review of the Pythagorean theorem, which we've been using all year, so that's nothing new. But what will be new to you is its converse and how we use that to classify triangles, okay? But it's very similar to the Pythagorean theorem. So here we go. Again, here's our Pythagorean theorem. We use this to find missing sides in a right triangle. And remember, it has to be a right triangle. And we know that your hypotenuse. So here we go. Hold on one second, folks. My computer's just waking up this morning. Give it a second. Okay, hopefully you're all right. Okay, we know our hypotenuse, our C value is always across from that right angle. And that is that squared is equal to the legs squared, the sum of those two legs, right? So here's your hypotenuse, and here are your legs. Again, you guys know that, that's nothing new. And then probably moving forward, I will usually put that C value on the left side, and you'll see why I do that in just a little bit here. So C squared equals A squared plus B squared. So, nice little review problem, find the value of the variable. In this case, we are looking for our C, right? That's the side across from that right angle. Doesn't matter, I'm gonna call this one A and this one B, plug them into my formula, and we crunch out these numbers here. So x squared equals 15 squared plus 6 squared. Drop down your x squared, 15 squared is 225, 6 squared is 36. Add those two together to get 261. Square root of 261 is not a whole number, it's not a perfect square, so we can do your favorite thing of breaking down our radical. So we gotta figure out what perfect square goes in to 261. This one's kind of mean. You have to make your way all the way down to 9. 9 goes in there 29 times. Square root of 9 is 3, so I get 3 radical 29. Okay, perfect. Our next one here. All right, our C value is 11. I'm just going to make x a 9b. Plug into our formula. So we'll have 11 squared equals x squared plus 9 squared. 11 squared is 121. Equals x squared plus 81. Subtract over that 81 and we should get 40 equals x squared. Square root of 40 is also not a whole number, so we got to break down our radical. This one's a little bit more easy to figure out. Hopefully you're noticing that 4 goes into 40 10 times. Square root of 4 is 2. Can't break down the square root of 10, so 2 root 10 is our final answer. Okay, that was a nice review of simplifying square roots and finding or using the Pythagorean theorem to find a missing side of a right triangle. This next slide is more just kind of like fun information for you. A Pythagorean triple is a set of 3 non-zero whole numbers, a, b, and c, such that a squared plus b squared equals c squared. So a Pythagorean triple, you guys, are 3 sides to your right triangle that are all whole numbers. This is more for those people who kind of like to see patterns, people who just maybe want to know fun facts about math at the end of the day. It doesn't really help you or hurt you, it's just kind of a fun fact. 3, 4, 5, that's a very common Pythagorean triple. And then if you guys notice, any multiple of those sides will also be a Pythagorean triple, right? So if I plugged in a 1 here, 3 times 1 is 6, 4 times 1 is 8, 5 times 1 is 10, right? And same on with these other examples given here. So something for you to know. Again, doesn't hurt you or help you, just kind of a fun factoid. Now the new kind of meaty part of our lesson today is the converse of the Pythagorean theorem. And it's basically a test. So if we're given three sides to a triangle, we can use what feels like the Pythagorean theorem. I call it the Pythagorean theorem test to figure out if it's an acute triangle, a right triangle, or obtuse. Something you maybe want to highlight is always keep the C, which is your longest side, on the left side, so that it makes classifying much easier. So that's why I had that C squared on the left side instead of having it A squared plus B squared equals C squared. But here we go. So if your C squared value is less than A squared plus B squared, then your triangle is acute. If your C squared equals A squared plus B squared, we know that is a right triangle, right? Because this is the true definition of the Pythagorean theorem, and it only works for right triangles. And then lastly, if C squared is greater than A squared plus B squared, it's an obtuse triangle. And that should kind of make sense, right? If your C squared value is big, large, you should think obtuse. An obtuse angle is your larger angle. Similarly, if C squared is less than your other two sides, think small, which is acute when you think of an angle measure. So let's practice this and see what it looks like, folks. So determine whether each set of numbers can be the measures of the sides of a triangle. If so, classify the triangle as acute, right, or obtuse. So there's two pieces to this problem. First, we have to figure out, can these three side lengths here form a triangle? So this is probably back around Christmas time we did this relationship. And if you remember correctly, the two smaller sides given to you have to add to be larger than the third side. So we have to check that first. So my two smaller sides here are 7 plus 14, and we need that to be greater than 16. Well, 7 plus 14 is 21. Is 21 greater than 16? Yep, it is. So I'm going to circle yes. Yes, we have a triangle here. Now we perform that Pythagorean theorem test. So your C squared is going to be your largest side given to you. That would be my 16. So I'm going to have 16 squared. I'm going to leave a space because I don't know what that symbol is yet. And then the order of the next two sides don't matter. So 7 squared plus 14 squared. And now you guys, it's calculator work. 16 squared is 256. Again, I'm leaving that space there. 7 squared is 49. 14 squared is 196. We'll simplify. 256. I'm going to leave that space there. 49 plus 196 is 245. And now I compare. How does 256 compare to 245? Well, it is greater than, right? Now, since I had a greater than symbol, that's telling me that it is obtuse, right? That greater than symbol there. So we would have an obtuse triangle here. Let's try the next one. Same thing, we gotta first figure out if this triangle or these three side lengths form a triangle. So again, take your two smaller ones, 9 plus 40. We need that to be greater than 41. 9 plus 40 is 49. Is 49 greater than 41? Yep, sure is. So circle yes. And now we're going to do that Pythagorean theorem test. Remember to pick your largest side, that's your C, which is 41. So we're going to have 41 squared, leave a space, 9 squared plus 40 squared. Now again, it's just calculator work. So 41 squared is 1681, leaving my space. 9 squared is 81, 40 squared is 1600. Add those two together, 1681, leave your space. 81 plus 1600 is 1681. How do those two numbers compare? Well, they are equal. And since they are equal, we know that is a right triangle. Okay, and then our last one here, folks. Have some decimals, but the process is still the same. So again, we first have to figure out, do these three side lengths form a triangle? So 6.2 plus 13.8, is that greater than 20? 16.2 plus 13.8 is 20. Is 20 greater than 20? No, they're equal. It's not greater, so this would be no, and then you're done. We can't classify the triangle if it doesn't even make a triangle, right? All right, thank you for watching this video. You're the best. Goodbye.